Okay, let's unpack this. We are taking a deep dive today into a product that sits on almost every bathroom shelf, something we use, well, almost every day for crucial protection: sunscreen.
Right, and it's this ultimate paradox, isn't it? Kind of wrapped in a lotion bottle. You put it on thinking you're doing the right thing, protecting your skin.
Hmm.
But the research we've synthesized for you, it reveals this really startling conflict. This thing we see as essential protection is having a decisive, um, catastrophic impact on ecosystems that protect the whole planet, our coral reefs.
It's a kind of glitchy reflection, isn't it? We're so focused on our own immediate health, but without meaning to, we're stripping away the ocean's environmental armor.
Exactly.
Yeah.
So our mission today is really to get beyond that surface layer. We need to pinpoint the specific chemical culprits mentioned in the sources, understand the honestly astonishing scale of their toxicity.
Astonishing is the word.
Right. And most importantly, pull together the clear, immediate actions you need to take to switch to alternatives that actually work and are, reef-friendly.
Okay, let's start with the chemicals themselves. The research seems very clear on the two main agents of destruction here. They're in countless common sunscreens, and when they wash off into the water, that's when the damage starts. We're talking about oxybenzone
Oxybenzone.
and
Now,
octinoxate.
those are the two big ones. And what's fascinating, or maybe disturbing, is that this damage isn't from some, big industrial spill.
Oh.
It's coming from billions of really small actions. Millions of people just swimming or showering off every day. These chemicals, they're designed to absorb UV light on your skin, but once they hit the marine environment, that chemical interaction turns toxic for corals.
And the effect, even in tiny, tiny amounts, is devastating. These chemical filters, they can trigger viral outbreaks in corals, bleach them white, kill them. It's not slow. It's immediate, disruptive.
It really exposes just how fragile the whole system is. Bleaching, as the sources point out, isn't just the coral changing color, it's the coral actually expelling the symbiotic algae. They're called zooxanthellae.
Zooxanthellae, right?
Yeah, they live inside the coral tissues, provide food, provide color.
Yeah.
Without that algae, the coral literally starves.
Okay, here's where it gets really, really interesting. Because the scale of this toxicity, it's genuinely hard to wrap your head around it until you see the analogy the sources use. To show how potent oxybenzone is, they ask you to picture an area the size of a standard swimming pool. Think about that much water.
Okay, yeah.
Yeah.
A lot of water. Massive dilution, you'd think.
You'd think. And yet, the sources reveal that just one single drop of oxybenzone,
One drop.
one drop in that entire swimming pool volume, is enough to cause significant damage to corals.
Wow. One drop. That's genuinely hard to process. It completely redefines what we think of as a tiny amount. It tells you the concentration needed to cause cellular and genetic damage is almost infinitesimal.
So how does that even work? How can something so small have such a massive impact?
Well, the answer, as the sources clearly state, is that the entire marine system is just incredibly fragile and connected. We're essentially pouring a chemical known to disrupt DNA and endocrine systems into an environment that just isn't built to handle it.
So realizing the power of that single drop, it just forces you to ask, why are we risking such a critical ecosystem? Which naturally brings us to why the reefs themselves matter so much. We often think of them as beautiful, maybe exotic, but distant.
Right.
But the sources really stress how tightly their fate is linked to our own choices, and frankly, to global survival.
Yeah, if we connect this to the bigger picture, the ecological importance of reefs is completely out of proportion to their physical size. They cover less than 1% of the entire ocean floor.
Less than 1%, that sounds like almost nothing, a tiny fraction.
Exactly. It's easy to dismiss. But despite that tiny footprint, those areas support an astonishing 25% of all marine life.
25%, a quarter.
A quarter of all known ocean species depend on coral architecture. Think about that density of life packed into such a small zone. It's an ecological powerhouse. Fish, invertebrates, turtles, countless species rely on them.
So that density means they're vital for the food web, for global fisheries. And crucially, the sources call them the ocean's nurseries.
That's a perfect description. They're where young marine life starts out, where small organisms get shelter from predators, where that whole biodiversity reservoir is maintained.
And that reservoir isn't just for fish, is it? It connects back to us.
Absolutely. When we talk about human well-being, losing these nurseries has severe consequences. Reefs act as natural storm barriers, protecting coastlines from erosion, from storm surges.
Okay, practical protection.
Yeah, and they're central to the blue economy tourism. Fishing industries support millions of people. The source material really nails it. Without healthy reefs, the ocean cannot breathe life back to us.
So here we are, stuck in this central irony again, this glitchy reflection. We put chemicals on our skin to protect ourselves from the sun,
Mm.
but doing that poisons the very foundation of marine life that provides global protection for all of us through climate regulation, coastal defense.
It really sets up a powerful ethical question, doesn't it? It forces us to look beyond just our individual convenience and see that our choices have these huge global ripple effects, which leads directly to that core ethical mantra from the sources. What heals us must not harm the sea.
What heals us must not harm the sea. That really sticks with you.
It has to be the standard, right, for everything we use outdoors.
But the good news here is that this isn't a problem where the only answer is stop wearing sunscreen. That's not safe, not practical. The sources give us clear, actionable alternatives. So what does this all actually mean for you, the listener, next time you're at the pharmacy or packing for the beach?
Right, the path forward is actually quite clear. Step one is, well, logical, focused elimination.
Okay, action one, avoid. You need to explicitly, actively avoid sunscreens using those known chemical culprits. Oxybenzone or octinoxate, check that label. Those are the ingredients to watch out for.
That's exactly. Action two, choose the alternative. And this means opting for mineral-based sunscreens. The sources specifically point to zinc oxide and titanium dioxide as the preferred active ingredients.
Okay, wait. If oxybenzone and octinoxate are these organic chemical filters, how are zinc oxide and titanium dioxide fundamentally different? Why are they the safer choice for the ocean?
That's a really critical distinction for people to get. Oxybenzone absorbs UV light through a chemical reaction. Great for skin, but problematic when it reacts with coral algae, especially with heat.
Okay.
Zinc oxide and titanium dioxide, on the other hand, are physical blockers. They literally sit on top of your skin and reflect the UV rays away, like tiny mirrors. Because they're inert minerals, they're much less likely to chemically interact with or disrupt the coral's biology.
That makes perfect sense. Reflect, don't react. Simple. But okay, when we talk mineral sunscreens, the sources add another layer. They must be non-nano. What does non-nano actually mean, and why is that detail so crucial?
Right, non-nano refers to the size of the mineral particles themselves. A nanoparticle is technically anything less than 100 nanometers across. Very, very small. If the zinc or titanium particles are nano-sized, they might be small enough for coral polyps or other tiny marine organisms to ingest them.
Ah, okay, so they could cause internal problems.
Potentially, yes. The non-nano label means the particles are larger, too large for the coral to easily consume. They're much more likely to just settle harmlessly on the seafloor or stay suspended without getting absorbed into the organisms.
So if the solution seems pretty clear, avoid the bad chemicals, choose non-nano mineral blockers. Why isn't every sunscreen on the shelf like this already? Is it a regulation thing or cosmetic?
It's a bit of both, really. There are challenges. First, historically, mineral sunscreen sometimes left that, white, chalky look on the skin.
Yeah, the ghost look.
Exactly. Manufacturers often use nanoparticles to make them spread easier and appear more transparent. Technology is improving, though. Second, cost and regulation. Getting a product certified as truly reef-safe can involve expensive, voluntary testing. And the term reef-safe itself isn't always strictly regulated.
Which brings us to the third action point, right?
Precisely.
Action 3. Pick products that go the extra mile. Look for labels that say biodegradable and reef-safe. And even though we know reef-safe can be a fuzzy term sometimes, choosing those products signals demand. It tells manufacturers we want that higher environmental standard.
It really creates a clear roadmap for responsible consumer choice, doesn't it? It takes this sort of abstract tragedy of coral bleaching and turns it into something concrete you can actually do right now. It reinforces that deep connection between your individual choice and the global impact.
So every time you check that sunscreen label, you're kind of casting a vote for the ocean's health.
You really are. And that, in turn, protects us all. We have to remember that closing thought from the sources. Every reef is like a heartbeat of the ocean. By consciously changing our habits, by protecting those vital heartbeats, choosing that non-nano mineral protection, the ocean will keep sustaining and protecting us. Its resilience depends on our choices.
It just brings us back to the sheer power of tiny things, doesn't it? One drop of poison on one side versus one small conscious choice you make at the store on the other. So if a single drop of an everyday chemical can inflict such systemic damage on these huge foundational systems that support all of us, it makes you wonder what other seemingly harmless everyday products might be affecting the unseen, critical environmental processes that keep everything running. Keep that question in mind next time you shop, and keep asking yourself that ethical standard we learned today. What heals me must not harm the sea.